So here we have another type of optimization problem. So we have a parabola shifted down 7. So this h of x equals x squared minus 7. And we want to find the point on this parabola that is closest to the point 57 comma negative 7. So let's let x comma y be a point on h of x. So we are trying to minimize the distance between this curve and the point 57 comma negative 7. So we're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so using our 2 points, we have the point x comma y and 57 comma negative 7. We can write this as x minus 57 squared plus y minus a negative 7 squared, so it'll be y plus 7 squared. But now I need to express the distance between these 2 points in just one variable. But I know that y is the same as x squared minus 7 because that's what I'm told. So I can write this as the square root of x minus 57 squared plus x squared minus 7 plus 7 squared. And if I simplify that, I will have x minus 57 squared plus x to the 4th, since those 7's cancel. Now, I'm going to want to find the critical values, so I'm going to need to take the derivative and set it equal to 0. So I'm going to rewrite this so that I can use the power rule. So I'm going to write this to the 1/2 power. So now I want to take the derivative of the distance. So the derivative in terms of x. So using the chain rule, I'm going to drop that 1/2 down in front. Decrease it by 1. And then take the derivative of the inside. So that will be 2 times this x minus 57. Decrease that by 1. The derivative of the inside of this is just 1. And then the derivative of x to the 4th is 4x cubed. So now if I rewrite this, I'm going to have 2 times x minus 57 plus 4x cubed all over 2 times the square root of x minus 57 squared plus x to the 4th. And I have a common factor in all my terms of 2, so I'm going to divide that out because this is already a mess. So when I divide 2 out by each term, I will have this. So I want to set this equal to 0, and I want to solve for x. Now, looking at my denominator, this is a distance. It is never going to be 0 or negative, so I don't have to worry about the denominator. I'm setting this fraction equal to 0, so I'm only looking at where the numerator equals 0. So I'm only looking at where 2x cubed plus x minus 57 equals 0. So notice I rewrote the numerator. We do not have an algebraic way to solve this equation, so we need to look at the graph of this. So if you put this in your graphing calculator and look at the graph, you'll see something like this. It's a curve, but the point is we're looking for where this equals 0, so we're looking for where it crosses the x-axis, and we can see that it crosses at x equal to 3. So I know here that my critical value is that x equals 3. That's my x coordinate. This says to give your answer as an ordered pair. So I'm going to find the y by putting in 3 into the function, which is 3 squared minus 7, which is 2. So my ordered pair will be 3, 2.